Good morning, students. I am Munshi Rashidul Islam, Assistant Professor, Department of Mechanical Engineering, JIS College of Engineering. Now, today I am discussing about the module that is actually gear drives. And now today is the lecture number 22. And actually, in this regarding topic, the lecture number 2. Gear drives lecture 2 is actually today's class. So that means, yes, last day we have discussed about the different types of gear and its application, and that are the continuation. Today's class is the continuation part of the last day classes, and that is the types of gear drives and applications. So regarding this, we can discuss about the spark gear terminology. Spark gear terminology means various points are to be mentioned in the gear drives. If you ready to design any spark gear, so first of all you have to know about the different types of gear terminology term. So first, in this regard, the teeth are straight and parallel to the gear shaft drives. Number one cases. Number two cases, the establish gear tooth profile using a involute curve. Involute curve, that means that is actually under some certain circumstances the involute profile of mating teeth overlap. That means this leads to undercutting the weakening the base of the teeth, reducing another beam strength. That means you have to design the gear teeth profile according to the application and according to the purpose of the basic concept, where it is to be needed according to their performance. Now, two types of teeth profile we have used. Number one, involute teeth profile, and number two, cycloidal teeth profile. So the next point is pressure angle. Pressure angle, that means it is some imaginary angle which is actually used to draw the gear teeth profile. To draw the gear teeth profile, that is the pressure angle. That means it is also called as an angle of obliquity, and it is actually the angle made by the line of the action with the common tangent to the pitch circle of the two meshing gear. So the line of action is common to the tangent of the base circle of the mating gear, and it is denoted by the Greek letter phi. Now next point that I missed, and that is the module. What is module? So module is actually the basic term regarding the spark gear design. So that, sorry for the interruption, that is actually yeah. Now the pressure angle, and the two types of standard pressure angle we have used. One is 14.5 degree pressure angle, and another is 20 degree standard pressure angle. Next point will be module. So module is actually the part of the, it is actually the ratio the diameter of the gear and to the total number of teeth of the gear. That means in module is denoted by small m, English letter small m. So small m is equal to diameter of the gear, that means capital D, and total number of teeth used required for the design. So that is capital D by capital T. That is module. Next point is diametral pitch. Diametral pitch is actually the vice versa of the module. That means module is defined diameter by total number of teeth, but in diameter pitch it is actually the ratio of the total number of teeth of the gear divided by the total diameter of the gear. So in diametral pitch is equal to 1 by m, that means 1 by module. Now next is contact ratio. Contact ratio, that means it is actually the number of pair of the teeth when the teeth are engaged in any instant is called as a contact ratio. That means suppose the total number of teeth of a gear or pair of teeth are in connected or engagement at any instant point of the another gear, that is called the contact ratio. Next, gear accuracy. Gear accuracy, that means the maximum tooth to tooth clearance, clearance or tolerance allowed as specified by the American Gear Manufacturer Association, that is the short form is AGMA, and it is called actually the accuracy. And several additional formulas are also there, just like next point is pitch circle and the pitch circle, it is actually the diameter of the pitch circle, and it may be defined as a equal to the product of the module of the module of the gear wheel, and the number of the teeth of the wheel. Now next, tooth thickness. It is basically a point where the tooth are engaged in some manner, where the tooth are engaged to the next gear teeth with some certain portions where to be connected or contacted to the another gear teeth, that is called the tooth thickness. And next, center distance. When the two gears are connected in such cases, that means suppose the one shaft centered to the another shaft center, that distance is called as a center distance. That means when the two suppose in spark gear cases, that two gears are in two separate shafts, so center to center distance from the two gears is called as a center distance. And next is circular pitch. That means it is actually the peripheral part and measured along the pitch circle. And circular pitch is actually the distance between the two similar adjacent point of the teeth. So circular pitch is denoted by P for pitch and C for circular. So PC is equal to pi into D by M by pi into D by T. That means module into pi is equal to circular pitch. So just we summary the conclusion part of the gear terminology term. We have know about this class, that is the module, circular pitch, diametral pitch, contact ratio, gear ratio. We just forget what is gear ratio. So gear ratio is actually the ratio of the total number of teeth in the driver driven to the total number of teeth in the driver. So that means D2 by T1, that is equal to D1 by D2, and that also equal to N1 by N2, while N1 is the total speed in RPM speed in driver, and N2 is equal to RPM speed in driven member. Now another point also be there, that is the bevel gear. So bevel gear mentioned different types of bevel gear. So that means the teeth are formed on a conical surface used to transmit motion between non-parallel, non-parallel and intersecting shaft. That means if you see the figure, the black portion of the left hand, right hand side of your figure, that is the main shaft, parallel shaft, and another shaft which is actually on the upward direction, and white section are also defined in your figure. So that's why the two axes is coincide at an angle with about 90 degree. So non-parallel, obviously in bevel gear cases the shaft may be non-parallel, maybe means obviously non-parallel, and intersecting shaft. So that's why that type of gear is called the bevel gear. Straight bevel gear, spiral bevel gear. That is the same function, just the complicated design may be some different issue. Crown gear. That means the similar type of prototype gear, special form of the bevel gear, and has right angle to the plane of the wheel. Obviously the gear are mainly in model type or prototype type, and it is formed some angle, special angle, and that angle is also calculated is bevel angle. And the gear is this type of gear is used for some light function, just like toys, any type of hand wristwatch, etc. Ohm gear. That means that is actually the figure of ohm gear. If you see the actual cases and function of the ohm gear, it may changes the direction of the turning motion. Near about the 90 degree. It also decrease the speed of turning from screw to the gear or increase the force. It just like just like a rack and pinion gear, but some difference are there. The lower portion of the gear, that means the gear portion is straight, but the upper portion, that means the wheel portion, ohm portion are also some inclined plane also be there. So that's why that type of gear it decreases the speed of the turning from screw to the gear and increased the force. That is actually the figure or graphical view of the gear of ohm gear. Pitch tolerance is actually plus minus 0.002. Interperfect gear data analysis, and by the some certain software used like ANSYS or any type of process, or one simple data are also given, and we can just draw a pictorial view of the ohm gear data point. And it is actually used for a ohm and ohm wheel, large speed reduction in a small spaces, and that we can get in this regard. And ohm locks in place when not in operation. That means if it is in running conditions, no locking portion is there. Now that is actually the view of rack and pinion. Just see the rack pinion are rotating on the upper portion, and in the lower portion the rack are converted, rack are running just like a linear speed, with a linear speed. In that cases, the convert the rotary motion to back or in fourth motion. That is the view of the rack and pinion cases. Now next, and it is also a similar slide, and in this slide, spar pinion operating on a flat straight bar rack, and it can transmit motion, it can transmit or it can convert rotary motion into the straight line motion, rotary motion to the straight line motion, and that is basically the main function of the rack and pinion type gear. And that is actually the line, that means in this figure, we can see in the actual cases of practical example. In this this is actually the figure of the railway track, where the some cases we can use the rack and pinion observation. Differential gear, and in differential gear, that means in some different type of gear we can use, and this type of gear more accuracy cannot be more accuracy can get in the differential gear, and in these cases split the torque in two ways, allowing each output to spin at a different speed. That means it is a complicated design, and power source can transforming from prime mover, that means from the motor to the main driver, and that different view that means the different differential gear are also be attached in some cases with some complicated figure, and in these cases the accuracy should be more high than the other gear drives. And spar gear that I already mentioned, so there is no needed of the spar gear again, because we can discuss this slide and we can discuss this portion in the first classes. An advantage of spar gear, that means it may be economical, simple design, ease of maintenance, so no slipping chance also be there, and also the compactness design also be counted and during the spar gear design. Now some disadvantage also be there. Number one, less load capacity. Number two, higher noise levels. Number three, higher maintenance cost. Helical gear, that also explained in the last classes. The teeth cut at an angle, that angle known as the helix angle, and the most of the cases it also be similar to that of the spar gear, except the some certain angle also created between the two gears teeth. That angle is known as the helix angle, and the function is more or less the same to that of the spar gear. Cross helical gear, it is also known as the right angle helical gear and spiral helical gear. It is used for the low load capacity and low load carrying capabilities. Helical gear with more loads than equivalent size spar gear operate more quietly and smoothly, develop end thrust, and also eliminate some angle which is not ignored during the whole process of the helical gear and design cases, and develop some end thrust. That end thrust may be counted or not. If you ignore, you can follow the design data handbook where it can be ignored and how much portions that can you ignore, and can also be eliminated using double helical gear, such as the herringbone gear. It is the simple and the moderate form of the helical gear, and specifically it is known as the herringbone gear, and that design is similar to that of the helical gear. Suppose some application is special for the purpose of the helical gear. Now from the last two classes we have discussed the different types of gear and their application, advantage, disadvantage, and the gear terminology, etc. Now next classes we have discussed with a new topic and with a new lesson. Thank you.